So if you think JWTs are awesome, think again, because in this particular video tutorial, we're gonna see best practices that you should follow as a developer to secure your JWTs and your applications. And also we're gonna see how hackers or malicious users can use those JWTs and can steal them from your application, from your users, that in ways that you don't know. So in this one, we're gonna take a look on all of those. We're also gonna take a look on the best implementation to invalidate or blacklist different JWTs, but still use the actual feature of JWTs being stateless on the server using different stuff like Redis and keeping that cache and middlewares and Express and all of that. So without further ado, guys, let's go ahead and jump right into it. So in order to get started with JWTs and understand what are the best practices we need to apply to secure our servers, our APIs, and to make our applications a lot more secure with JWTs, we need to go through the basic aspects of how JWTs are generated and how they work and why actually we use JWTs in the first place. So in this particular slide in here, I got like a brief introduction to what are JWTs. I'm not going to go through all of those, but if you are not familiar with JWTs just yet, you can read more about this and how they work. Of course, JWTs are just like tokens, and we sign the tokens, we encrypt the tokens, and we return them. And the tokens are going to just basically represent or allow users to authenticate into our API and access different resources. That's what it is. Of course, they are generated upon login. So if every user, when he provides a password and an email or a username, he can get a JWT back and he can log in. And when we generate a token, there's specific libraries, specific set of standards and algorithms we use to encrypt those and sign them off, and we use those particularly. So that's all being handled for us pretty well. And once we got the JWT and once the user wants to access something, he can authenticate, and of course we're going to verify that particular token. So this is a basic like workflow verification the token. Now I want to go deeply into like why is it used wrongly and what is going on wrong with this particular way, and like how you should probably secure this and how you should think about it. So if we take a look on JWTs, they are just tokens and they allow you to like use those tokens in a stateless way. That means you don't need to keep state on the server side, and that's why JWTs exist. That's why they just keep it this particular payload that keeps, for example, the user ID that is currently authenticated and everything. And of course, they are encrypted and everything. So one thing, or like there's always three things that you should consider in authentication. Signing tokens means encrypting the tokens and making sure the tokens data is not accessible by anyone on only your server or yourself. You need to have a secure transport, and this, of course, this can be happening just like an HTTPS or using SSL, so make sure to do that. And last but not least, which is the most vulnerable part of all of this, is securing the storage. And what I mean by securing storage is actually putting or saving those JWTs in a secure place, because if you don't save them in a secure place, you're going to have, you know, a lot of pitfalls and a lot of issues regarding that, and you're going to allow like side parties will allow hackers or anybody else with bad intentions to use those JWTs of your users and to actually access their resource on behalf, and it can do plenty of stuff like from XSS to CSRF and session hijacking and plenty of stuff that you don't want to have. On the other hand, if we jump to the diagram, like a user who wants to log into a server, he basically just, of course, logs into the server is going to send back the JWT token, is going to sign the token and everything. And this is just going to be a short-lived token. So like it has a pretty small expiry date, and that's one point I want to talk about. So once you've got the token in here, the browser needs to handle storing the token so it can send that token with every request made after login. So, you know, you can, to allow basically users to authorize after login, you have to send that token and tell the server, hey, I got this particular token, I can access this particular resources, and I have the authority to do so. So for that particularly, what happens, you can actually save it into two places. One is the local storage, which is the easiest and the most simple place, but still, it's actually so vulnerable and it's so bad practice to store it on a local storage. And you can do it on cookies, and particularly HTTP only cookies. So you can save them on two places in here, and I'm going to give you this, like in this particular video, an example between a difference between storing to the local storage and what are the vulnerabilities from XSS to CSRF that's going to, you know, just going to expose to your server when you do it on local storage versus when you do it on HTTP only cookies, and why the benefits, what are the benefits in this particular. So for our demo projects in here, we got actually two projects. We got the front end project, which runs React and uses Axios to, you know, just do the HTTP request and authenticate authenticate and everything. And on the other hand, we got Express.js in here with passport.js in here. And passport.js, of course, as if you're not familiar with this, is going to allow you just to basically authenticate and use like JWT authentication and do plenty of stuff. So we are using in here to do JWT authentication and to extract that from a bearer token. So I'm using this as simple as possible. I'm using the local storage. Both of these projects right here, like, read from the local storage, no cookies included, just the local storage. And this is the basic way most of people just implement authentication this particular way. So you can find, of course, the projects in GitHub in here just to see it yourself. So I'm just going to go through like the basically how the projects works. And for the demo application, it's just basically a login. So a login screen in here that allows you to authenticate and everything. So once you head over to this, you can just go and click onto like the email or the password, and you can enter that. As you see, welcome back, authenticating, and it's going to store the API token. So as you see, this is the API token. This is the JWT. This has been stored into the local storage, right? For that particular website, localhost 3000, and of course, some user information in here, which doesn't really matter. So we got just the API token. This is what we need for now, and this is the JWT. So this is when I'm using local storage, of course. And now once I, for example, go to the dashboard, I will be able to authenticate, and the dashboard in here is going to do plenty of requests. One of these requests is going to do is the payment. So it's going to do a request to the payments API, and it's going to send, like, not response, but request headers. It's going to send the authorization as a header, right? As a bearer header in here. And this is basically what the authentication works and how JWT actually works from a local storage. So you send it on the header, and the server is going to authenticate. It's going to return 200. It's going to allow you to access the resource, for example, a payments gateway or payments endpoint that is protected by that API. Pretty simple, and that's how it works. And if you quickly take a look on the login form in here, what we're doing is basically using the local storage and storing both the API token and the user. And of course, the user in here, as long as you're not storing like sensitive information or like password and encryption keys or anything related to the security side, you're just basically good in here. If you're just storing just metadata info, most likely like 90% you're going to be good, but there's always a 10% you can be compromised. So there is an API token in here, and this is what we care about. This is our JWT token, and it's being stored on the local storage. So once you log in, once the submit in here, once the request or response is came back, so once you got the response in here, of course, you're going to just like navigate to the dashboard, whatever, you're going to store the authentication, and you can call it a day. That's the simplest part, and that's how it works. If we jump back to the server in here, it's basically using the strategy I said before, the passport strategy, which basically checks that or like extracts that from the header as a bearer token. Remember, we're sending it on the authorization header, and of course it has a max age and everything. It looks for the user, it finds the user, then it's going to allow you to authenticate. If you use this particular middleware in here just to do passport authenticate, it's going to allow you to access this because of course, the JWT is valid and everything is working fine. Now, why this approach is absolutely bad, and you should always avoid this at any cost. So if I jump back in here, and I'm just going to give you a quick example of XSS and how this could be very bad. So since this particular application is pretty small, right? You can't have XSS unless you implement that. And that's what I did in here. I implemented an XSS vulnerable input. And if I jump back to this particular input in here, that should be on the dashboard, and if you head over, that's just like sets an inner HTML, right? Because React by default escapes any HTML stuff, but once you do dangerously set inner HTML, you just like have no warranty anymore. So that's what I'm doing in here. I'm just creating this XSS. But if you are having this big application, a medium-sized application, even a small application, you can have XSS anywhere inside of your inputs. Like, you can't imagine how like you can get an XSS and you can't actually figure it out. So it's very bad to do that, and you can always assume your application has an XSS. Okay, so I have an XSS in here, and I have an XSS vulnerable input. I don't care how, but you can execute XSS on your application, and that's all I care about. So I got particular different payloads in here just to try XSS payloads particularly. So I'm going to try this particular payload that's going to run an alert just to check that this one has an XSS, and as clear as any, when I put an image in here, as I'll see, and I can run custom JavaScript code, and that's what actually happening in here. That's pretty good. I just have an alert. Now, what can an alert hurt me? Because that doesn't sound like really dangerous, because you're just doing an alert. Just, hear me out. With an alert, like, you can start from an alert, but what you can end on, you can have an alert, but this alert can have the JWT token. Like, That's crazy. That's your token in here. And if you head over to the application right over here, you can find this is the exact same token, and anybody can access that token because they can run suspicious or malicious kind of JavaScript code inside of your application, and they can access local storage because JavaScript can access local storage, and that's a pretty bad bones. So just putting this XSS in here, which can run and do everything, that's pretty bad. I mean, like, you can get the local storage, you can get the API token, you can do plenty of stuff. So as long as you can execute JavaScript and you can access the underlying JWT token, which is the local storage, you can do whatever you want. And the hackers can have fun with your website. And I've got another payload that is pretty suspicious, and it's actually, it can actually steal your JWT token. You can send it to a server and it can save it on a server. So this payload in here, just, it's an image. Again, it uses XSS vulnerability, and it does one error. Then it just uses XML HTTP request module. It opens a new request to a particular API, and I've actually implemented the particular or simple API to steal a token. Then it just like appends that token from the local storage API token to the token, and he adds it to the HTTP request. Then he sends that request, all just by executing it on your input. And why is that? Just because you have your JWT token on local storage, hackers can actually do that. If I jump to my server, I got a simple endpoint in here that allows you to steal a token, and it can grab the token from a query and plenty of stuff. And this is actually very dangerous, and you can just like, you can grab it from a query, you can save it on a database, and this API of yours can be a hacker's API, and it can steal different JWT tokens, and you can use them for evil stuff. So yeah, keep in mind in this. So let's go and try this particular payload. I've got the input in here. I'm just gonna click on this. I pasted it. I see nothing really, like nothing happened. Okay, if I go to the network tab, I'm gonna see something suspicious. There's like a hidden network call made, and there's token is stolen, and the headers are pretty simple, but the payload is actually our token. Wow. If I jump to the server, if I go to the logs, because I'm console logging this, I got the stolen JWT token, and this is actually the stolen JWT token. It's actually, this is what it is. And why this particular one happened in the first place, I'm not going to say XSS, because XSS could be like happening in every application, and you can't mitigate XSS. So it's very hard to mitigate or very hard to fix your XSS. Even though you need to find and fix those particular XSS vulnerabilities, you still can't control that. Unless, or in the other side, or in the other hand, what you can actually control as a developer, and the easiest way, of course, it needs a little bit of just, you know, changing here and there, but the easiest way and the most actual way to do authentication, to implement authentication, is to use HTTP only cookies. So if you're still using JWT tokens and saving them on your local storage, the first thing, or the easiest part that you can mitigate just right away, is actually to make these JWT tokens expiry date just like too little, like 2 hours or maybe 5 hours, something like this, something, or like a timing window that cannot affect that much. Then later on you can actually change it to HTTP only cookies. So just like a quick resort, you can just, you know, change the expiry date or the expiration time for this and just make it a lot lower. Now for HTTP only cookies, or just cookies in general, and particularly HTTP only cookies, and particularly, for example, in here, the login in here, this, I changed the projects in here to use HTTP only cookies. Now instead of sending the JWT token on the header, so you see I'm doing the JWT token, I'm signing the JWT token and everything, but instead of sending it back on a header or sending it back as a response, I'm not doing that. I'm just sending the user's data without a password, of course, and I'm sending that JWT as a cookie. And of course, if you're not familiar with how HTTP work or HTTP cookies, is once the server sends back a cookie, the cookie is going to be automatically set on the underlying browser for the particular local, or for the particular domain that, you know, the cookie owns. So that's particularly where it's going. Of course, you can set secure in here if you're HTTP or HTTPS and SSL. And because I'm just running this on localhost, I'm putting this false, but make sure to put it true if you're in production. And I'm putting HTTP only. And this is a very, very actual crucial approach to do it for cookies, not just cookies, but you have to do HTTP only cookies, because HTTP only cookies cannot be accessed by JavaScript. So no JavaScript code can access the HTTP only cookie, and the cookie is going to be sent automatically by the browser when particularly making any request to the underlying domain that the cookie has. So the browser is going to take care of handling the sending the cookie, and the server is going to read the cookie as it does for the headers. Basically, you just need to add just, you know, cookie parser, and that is it. And that's all you need to do. So HTTP only cookie cannot be accessed by JavaScript. That means you can actually run no XSS, or no excessive vulnerability can allow you to access that cookie, which means you cannot do like session hijacking, you cannot steal the JWT token, because the cookie cannot be accessed by the JavaScript. And that's actually a very good approach. So simply in here, I'm just doing the cookie in here, I'm just returning the cookie, and that's what it is. So you don't need to go through the details of how that particularly works. So just you got the cookie in here. Of course, on the other hand, in the front end in here particularly, I'm not setting the API token on the local storage anymore. I'm just going to leave that to the server to set the cookie, because the server is going to be able to return the cookie, and the browser is going to set the cookie automatically for you. So you don't need to do anything, just save the user in here, whatever metadata you need, and the authorization token or the JWT token is going to be handled by the server and the browsers themselves. Pretty easy. And if I take a look on the Axios interceptors, because before we were using the actual interceptors to intercept every single request and add that from API token from the local storage and add it to the authorization header, so to allow that. Now I commented this code because that's now needed. The cookie is going to be sent automatically by the browser, and when the response is coming in here, and when you have an authorized, I'm just removing the user in here because that's all I'm using for authentication. And because I can't remove the cookie needs to be cleared by the server, so that's a pretty good approach. Now if I jump back to the application real quick in here, so if I try now to log in with cookies and HTTP only cookies, I click enter, I'm going to be authenticated and get no no API token saved on the local storage, but I head over to the cookies, I'm going to find a new API auth, and it has a cookie, it has a domain, it has expiry dates, and plenty of stuff, and plenty of details, and it's just going to be working fine. So if I head over to the dashboard in here, you're going to be authenticated, it's going to allow you to access, you can access the payments in here. If I go to the payment route, that's going to work, and you're going to find cookies that are sent, like request cookies in here. It's going to send that every single time the browser knows and everything, so that would work fine. And of course in here, for this particular example, if we try to do any XSS, right, I've got the XSS in here, and I've got my server in here. So this is my server. I need to to be able to see if I can steal anything. Now if I put that in here, the actual is because it's XSS, it can still be called, but if I take a look on the token, the payload, it's null, because you have no access to this, the local storage is not accessed anymore, and you cannot access cookies, HTTP only cookies. And if I take a look on this, the token stolen and is going to be called as null, and as you can see, stolen JWT token is going to be null, and they can no longer steal your JWT tokens, and this is the best approach to secure JWT tokens in the first place. Also, one other thing you need to keep an eye on, so when you use cookies right now with Axios or with Fetch, so what you want to include is actually you want to include with credentials. You can include it per request, or better, you can include it as a default. So you can do Axios defaults with credentials, and you can set that to true for the Axios instance, of course. And this will allow it to send and set cookies and everything. So make sure to do that when you change from local storage to, HTTP only cookies. And the other very awful thing I completely disguise about using JWTs is actually the ability to invalidate or blacklist a particular JWT in a particular type. So for example, in here, you got a JWT, right? And you got an expiration time for that JWT, like for example, this one is from 7 days from now. And you won't be able, the server won't be able to unauthenticate or won't be able to delete and block this particular JWT if anything happens for that particular user, for security concerns or anything in that particular time. So you won't be able to do that. This can only happen once the expiration time is ended, because JWTs are stateless and you cannot keep them on the database or something. So likely there is a particular way, and they can make them still be stateless kind of stuff. You can still not include them or save them store them on the database, but rather you can store them on a Redis cache, like an in-memory cache, or just even in disk cache, because Redis is super fast and super powerful and not going to be storing that much of information. You can be doing it on Redis in here. So for example, right here, I got this particular example. It uses Redis, and of course, so what I do in this one is actually I use Redis to store an object. The key for this object is the user ID, and those are all the JWTs that the user got before and they were blacklisted. So any JWT is going to be added to this one is going to be blacklisted, and the server won't allow it to access that. Of course, you need to add a couple of different stuff, but it's actually pretty simple and pretty easy. So I really advise you to go to this particular repo to check how that is implemented. I'm not going to go into all the details, but that should be pretty simple. So we got the same thing with cookie extractor, we got the JWT, and I'm using the same thing. One another thing in here I'm adding is actually a logout route. Whenever the user hits the logout button and the request is sent to logout, I want to take this particular JWT of the current user and store it on the Redis, so just to make this as blacklisted and nobody else can use JWT because it can no longer be generated. And who, like, if the JWT was stolen before or anything compromised about that JWT, you can just make sure that JWT can no longer access that because the user logged out and everything. And of course you can have different types of different ways to include in the blacklist in here, but just this is a super simple example of how to do it. So once the log out in here, I'm going to authenticate to make sure there's a JWT. I'm going to grab the JWT. I'm going to access Reddit in here to make sure if there's already an user, and of course I'm going to save that user's particularly, or save that new token in here by just looking to the user and saving it. If there's new user, I'm going to create a new record for it, and so on and so forth, and that's basically what it is. And of course I'm going to clear out the cookie, so I'm going to do response clear the cookie, the API auth on the browser, so it can be cleared out for this particular user, and everything would be working fine. On the other hand, this is actually the way to add it to the actual Redis cache, and there is another middleware I created in here, and this particular middleware is going to check every single request if it has an invalid or it has a blacklisted JWT or not. So if it has a blacklisted JWT, it's not going to be allowing it to access the server. It's going to return 401 unauthorized HTTP, response. Otherwise, it's going to allow it to access through. What we can do is actually you can log in here, for example. Like, I'm going to grab this particular cookie value in here, or what I can do particularly just a little bit better, I'm going to go to Axios, right? Or sorry, I'm going to go to Postman, and Postman in here, I'm going to close this. I'm going to go to logout, right? And I'm going to try to do that. So for example, I'm going to be able to log in first. I'm going to click, I'm going to log in and send the password and everything. And here Postman, what it does, it keeps the state, right? So it keeps the state in here, and the actual name and the value are going to be kept in here. And it's going to be like, keeping the actual cookies. So whenever you do another request to the same domain, the cookies you saved before are going to be sent throughout that request. So for example, in here, the payments, I can do payments and it will be able to access the payment. I'm going to get that, I'm going to still get the cookie and everything, but that's going to be working fine. So that's a pretty good approach. Now let's go ahead and try, because if you remember, I'm going to copy this particular token that I used in here. I'm going to go to logout, right? Remember, I'm going to log out in here. I'm going to use the same token. I click on this. It says goodbye. That's pretty good. Cookies are cleared. There's no cookies back. If I head over back in here to Redis, and if I refresh, as you can see, there's a new token got added, and that's what it is. Now, it's actually blacklisted, and if you try to go back to Postman in here, and if you try to head over to the payment API, try to send a request, you're going to have an unauthorized, right? Because you logged out, and all those tokens and everything are, removed, even though the cookies are removed. So that would work absolutely fine. So anyway, guys, thank you guys for watching. I really hope you guys enjoyed this particular best practices for JWT and how to secure APIs, or how to secure a React application and browser application, and to make it absolutely like a standard secure application and make it absolutely work fine. So without further ado, guys, hope you guys enjoyed, and catch you hopefully in the next ones.